to another spherical moment. Can we learn math by reading solutions? In this video, we will consider this question using the following problem as an example. Prove that for any integer n cubed is either a multiple of 9 or 1 more or 1 less than a multiple of 9. You may pause the video here if you would like to give it a try. The proof. By the division theorem, an integer n gives a remainder of 0, 1, or 2 when divided by 3. So we consider the following three cases. Case 1, n equals to 3q for some integer q. Then n cubed equals to the cube of 3q and can be shown as a product of the factors 9 and 3q cubed. That is, n is a multiple of 9. Case 2, n equals to 3q plus 1 for some integer q. Then n cubed equals to the cube of 3q plus 1, which can be expanded using binomial theorem to get 27q cubed plus 27q squared plus 9q plus 1. We can factorize 9 from the first three terms. This shows that n is 1 more than a multiple of 9. Case 3, n equals to 3q plus 2 for some integer q. Similarly, n cubed equals to the cube of 3q plus 2, which can be expanded using binomial theorem to get 27q cubed plus 54q squared plus 36q plus 8. By rewriting 8 as 9 minus 1, we can show that n is 1 less than a multiple of 9. This completes the proof. Now let us look at the underlying proof strategy of the solution. Firstly, we apply the division theorem using 3 as the divisor. Then we consider cases based on all possible remainders, 0, 1, or 2. Lastly, we show that the statement holds in each case. This should be roughly the strategy to prove other similar questions. This is usually easily accepted by students, as it serves as a step-by-step guide to craft out the solution, except possibly for one minor part. Why do we use 3 as the divisor? How do we know 3 is the appropriate choice? Can we use 2 or 4 instead? Why didn't we use 9 instead, since 9 was the integer in the question? How do we know which integer to use for other similar questions? These are some common questions posed by students. I find these questions very interesting, or more precisely, a teachable moment. The questions highlighted a few points. The students were seeking clarity on applying the strategy more generally. Even though the entire solution was given, they saw a gap in understanding it, particularly on choosing an appropriate divisor. It seems that the learning is incomplete even after reading the solution. Can you figure out why 3 is chosen as the divisor? To answer this, let us start the investigation of the original problem, pretending that we know neither the proof strategy nor the fact that 3 is the chosen divisor. The question says that the cube of an integer n is either a multiple of 9 or 1 less or 1 more than a multiple of 9. Now we have no knowledge of how to proceed. This is often the case in research. There isn't a standard or routine way to solve every unanswered question. Hence, a natural small step is to verify the statement for some easy values of n, say from 1 to 10, and hopefully we get some insights from that. It's straightforward to check that when n equals to 1, n cubed is 1 more than a multiple of 9. When n equals to 2, n cubed is 1 less than a multiple of 9. When n equals to 3, n cubed is a multiple of 9. When n equals to 4, n cubed is 1 more than a multiple of 9. When n equals to 5, n cubed is 1 less than a multiple of 9. When n equals to 6, n cubed is a multiple of 9. You can check that the pattern continues. In fact, it seems that the pattern repeats itself after every 3 increments in the value of n. Furthermore, we observe that when n is divided by 3, if n has remainder 1, then n cubed is 1 more than a multiple of 9. If n has remainder 2, then n cubed is 1 less than a multiple of 9. If n has remainder 0, then n cubed is a multiple of 9. So this suggests to us to prove the above, generally for all integers of n. This explains the proof strategy and unravel the mysterious reason for choosing 3 as the divisor. In summary, reading the solution or proof convinces us the statement holds. We may also infer the underlying proof strategy from it. However, as rigorous as a proof can be, it may not give us a complete picture of the problem-solving process. There is an analysis or investigation, which is often omitted in the solution, but plays a critical role in solving the problem. This thinking exercise is probably easier to pick up by attempting the question firsthand and getting your hands dirty than reading the solution. This is why it's usually hard to learn math by just reading solutions or proofs. I hope you enjoyed the video. Please share, like, and subscribe for the latest video. Leave in comments any problems or topics you are interested in. Alternatively, you may email me. Thank you for watching.